This question is looking at the periodic trend of atomic radius and ionic radius. Here you're going to have to rank things from smallest to largest and explain your rationale. And we'll tackle it one grouping at a time. So for the first group, we're looking at carbon, nitrogen, and oxygen, and want to rank them from smallest atomic radius to the largest. The answer is that the oxygen atom is smaller than a nitrogen atom, which is smaller than a carbon atom. Now the question is why? Carbon, nitrogen, and oxygen are all in the second period. So they all have 2 energy levels, so that's a non-factor. Because oxygen has the most protons in its nucleus, it has the largest effective nuclear charge. Carbon, having the fewest protons in its nucleus, has the least effective nuclear charge, and the effective nuclear charge for nitrogen is in the middle. Coulombic force is directly related to the value of the effective nuclear charge. The stronger the Coulombic force, the more the electrons are pulled towards the nucleus. For that reason, an oxygen atom is smaller than a nitrogen atom, which is smaller than a carbon atom. The next three are beryllium, magnesium, and calcium. The correct answer here is a beryllium atom is smaller than a magnesium atom, which is smaller than a calcium atom. The rationale is all 3 elements are in the same group, which happens to be group 2. As you move down a group, an energy level is added for each period you move down. The more energy levels, the larger the radius. Since beryllium is in the second period, it is smaller than magnesium, which is in the third period, which is smaller than calcium, which is in the fourth period. The next trio is chlorine, argon, and krypton. In proper order from smallest to largest is argon is smaller than chlorine, which is smaller than krypton. The reason here, chlorine and argon are both in the third period. So they have the same number of energy levels, so we're not going to worry about that. Argon, having a larger atomic number, has more protons, so it has a larger effective nuclear charge than chlorine does. The larger the effective nuclear charge, the larger the Coulombic force. The larger the force, the more electrons are pulled towards the nucleus, so the argon radius is smaller than the chlorine radius. Now, let's toss krypton into the mix. As mentioned before, chlorine and argon are in the third period, while krypton is in the fourth period. That means krypton has more energy levels. The more energy levels, the larger the atom. So argon is smaller than chlorine, and because of the extra energy level, krypton is larger than both. Last but not least, we're going to look at the sodium atom, the sodium cation, which occurs when sodium has lost a valence electron, and the sodium anion, which will occur when sodium has gained an electron. The proper order from smallest to largest is the sodium cation is smaller than the sodium atom, which is smaller than the sodium anion. The rationale here, sodium has 1 valence electron. So when it loses 1 electron to form the cation, it also loses an energy level. This results in a smaller radius, so the cation will have a smaller radius than the neutral atom. When sodium gains an electron to become an anion, it still has 3 energy levels. The 2 electrons in that third energy level do have a repulsive force between them because they are the same charge. In order to minimize the repulsion between the 2 electrons, the third energy level expands. Therefore, the radius of the sodium atom will be less than the radius of the sodium anion, following the idea that if E is less than F and F is less than G, then E must be less than G. The sodium cation is smaller than the sodium atom, which is smaller than the sodium anion. And so utilizing appropriate atomic structure and Coulomb's law, all 4 parts of the question have been answered.